Finally, number 13. I'm going to solve the ODE y double prime minus 2y prime equals x plus e to the x. So here you could solve this using Laplace transforms if you want. You could solve it using the methods from chapter 4. If you want, there are other ways that you could solve it. You could use reduction of order. You could use variation of parameters. I'm going to solve it by first looking at the homogeneous ODE. So I'll ignore the x plus e to the x for the time being. And find the characteristic solution. If y equals e to the mx, then my characteristic equation becomes m squared minus 2m, which you could factor out in m to get m times m minus 2 equals 0. So that tells me m is 0 or m is 2. And my characteristic solution is c1 e to the 0x plus c2 e to the 2x, or just c1 plus c2 e to the 2x. And then I'll use the method of undetermined coefficients to solve for my particular solution. So for my particular solution, my first guess was ax plus b plus c e to the x. But I noticed that I had a constant term, the c1, as a solution for my characteristic equation. And so I had to multiply by x so that I did not have any duplicated terms. Notice e to the x. If I had the same exponent here, I would have had to multiply by x also. So our particular solution has the form of ax squared plus bx plus c e to the x. I'm going to substitute in for the first and second derivatives. My first derivative is 2ax plus b plus c e to the x. My second derivative is 2a plus c e to the x. When I substitute into the original equation, I get 2a plus c e to the x, that's my y double prime, minus 2 times 2ax plus b plus c e to the x is equal to x plus e to the x. Then grouping like terms, see I only have one x term, this negative 4ax. My constant terms are 2a and negative 2b. And then I have a c e to the x minus 2c e to the x. Those combine to give me the negative c e to the x. That's equal to x plus e to the x. So matching coefficients of like terms, my x terms have to have the same coefficients, which tells me that negative 4a is equal to 1, or a is equal to negative 1/4. My constant terms have to have the same coefficients, which tells me that 2a minus 2b is equal to 0. And then if I bring the b over and solve, it tells me a is equal to b, because a is negative 1/4, b is also negative 1/4. And then for my e to the x terms, I have negative c is equal to 1. So c is equal to negative 1. It tells me that my particular solution is a is negative 1/4, negative 1/4 x squared, b is negative 1/4, get negative 1/4 x, c is negative 1, minus 1 e to the x. And the solution to the equation is the characteristic solution plus the particular solution. So we get c1 plus c2 e to the 2x minus 1/4 x squared minus 1/4 x minus e to the x. That's our general solution.